Alright guys, now for question 4, what we've got is complex number z satisfying the following equation, okay? We need the answer in the form x plus iy. Right, how do we do this? Well, first things first, what do we need to do? Well, what I'm going to say is, okay, let z equal x plus iy. Let z star equal x minus iy. Perfect. So we got this sorted out. The next thing to do here is to, of course, plug these into the following, okay? So what we've got is x plus iy here plus x plus iy times I over x minus iy minus 2 is equal to 0. Okay. And in fact, actually, what I'm going to do here is we can rearrange this to just say equals 2 because I want to keep everything on one side. Okay, so now, pretty simple. All you have to do is the following. What we have to do is, okay, fine. X plus iy. Okay, then we got x minus iy. Okay, plus I x plus iy. This is all going to be over x minus iy. Okay, it's going to equal 2. Brilliant. Brilliant. So now what we can do is we can get this onto both sides. So x plus iy, x minus iy, plus I, x plus iy is equal to 2, x minus iy. Okay, cool. And then it's just a case of multiplying it out. So we multiply this out now, we get x squared minus xyi minus I squared y squared plus xi plus I squared y. Okay, it's going to equal 2x minus 2yi. Perfect. Alright. So, where do we go from this? Well, where we can go from this is we know that, okay, these are going to cancel. And, or minus, that's going to equal, or plus y squared. So what we get is x squared plus y squared plus ix minus y is equal to 2x minus 2y I. Okay. Alright. And in fact, we can go a step further just to rearrange it to make it to help us in the next part of the question. Because the next part of the question now is comparing like terms. Okay? If we compare like terms here, what we're going to get? X squared plus y squared minus y is going to equal 2x, whilst ix is equal to negative 2y. Okay, so x squared plus y squared minus y is equal to 2x. That's our first one. And we've also got x is equal to minus 2y. That's the second one. Okay. Excuse me. And this should be y. Okay, so what I'm going to do now is plug 2 into 1. What do we get when we do that? Well, when we do that, what we get is the following. Negative 2y squared plus y squared minus y is equal to 2 minus 2y. Alright, so what we get is 4y squared plus y squared minus y. Let's go to negative 4y. Brilliant. So 5y squared. Okay, and boom, boom, boom. Well, that's going to be plus 3y. It's going to equal 0. Perfect. So now we've got an equation. We can say fine y 5y plus 3 is equal to 0. So therefore, y equals 0, or 5y plus 3 is equal to 0. 5y is equal to negative 3, y is equal to negative 3 over 5. But we're going to ignore this. Okay? Why do we ignore this? Well, we ignore this, guys, because it's simply not going to give us a an answer that we actually need here. Okay? It's going to be a it's not going to get us anywhere, because obviously you plug y equals 0 into this, and you know it doesn't tell us anything about y. Okay, so negative 3 over 5. Cool. So now we're going to find x. Well, what's x? X equals minus 2y. So therefore x, okay, which equals what? 6 over 5. Brilliant. So guys, we got x, we got y. Therefore, what we can say is z, and more specifically here, yes, we can say z is going to equal 6 over 5 minus 3 over 5i. And that, guys, is going to be the final answer to part I. Alright, guys, now for BI. For BI, it's pretty much a case of saying, well, the following. So, what it wants from us is saying a single Argon diagram, sketch the low key given by z minus 2i and imaginary z. Okay. First thing you need to know, okay, z minus 2i equals 2. It's the same thing as saying basically that z minus 0 plus 2i is equal to 2, right? Which effectively means we'll have a circle, center here of 2i as relates to the axis, and radius 2. Meanwhile, imaginary value of z equals 3. It's pretty much just saying that it shows the imaginary part where all values of the imaginary value equaling to 3 occur. So how do we put this together? It's very simple. All we have to do is we're just going to draw an axis. Of course, the low key is going to be the line connecting them. So we've got boom, boom, boom. Okay, got this here. We have 2 in the center here. 3, 4. Okay, it's got 3 around here. So we have 3 here. Okay, so y is equal to 3. Okay, we've got 2 here. Now note that the low key then is then going to connect these both. Both over here, okay? And let me just see anything else. Sketch, yeah, oh, it's unlucky. Okay, brilliant. Let's go right angle here, and then yeah, that's the start for I. Alright guys, now for II, we have to do the following. So it tells us here Okay, it says in the first quadrant, the two loci intersect at the point P. Find the exact argument for the complex number represented by P. So that's over here. Alright, so it intersects at P. So what we need to do is firstly we're going to label this triangle. So we're going to say find out C, P, and put R over here. Okay. Now, what we can say is in triangle CPR, because remember what we're trying to find here, okay, is the argument of the complex number represented over here. Okay, so we're trying to find the a degree of intersection here. So, I'm going to say fine. PR is going to equal 2 squared. Okay, so this here is going to equal this minus CR. Okay, so CP minus CR. Now what is CR? Well, this is going to equal 1, right? Why? Because remember, it's got a radius of 2. Therefore, this bit is going to be 4. So therefore, this must equal 3. And we know that because y equals 3, but just clarifying. Okay, so we've got 2 squared. We've got 2 squared here. Minus 1 squared, which is going to give us root 3. Right? Perfect. PR equals root 3. So what we can say then is, okay, cool. This is going to be root 3 units. Okay? And so what we can say then, therefore P is going to equal root 3, 3. Okay, because you're going to go across root 3, and you're going to go up 3 units. Brilliant. You have that. Now, you can therefore say, let's get the root 3 plus 3i. Okay, so if we want to find the argument now, what we have to say is, okay, fine. The argument of P is going to equal arctan of 3 over root 3, which is going to equal, from here, this is going to become 10 root 3, which is going to give me pi over 3, guys. Okay, and that is going to be the final answer to that question. Alright guys, now for the next one, question 5. It's saying us to solve the equation 1 plus 2i w plus I w conjugate is equal to 3 plus 5i, and it says give your answer in the form x plus I y where x and y are real. Okay, cool. Well, what I'm going to do here is the following. Firstly, what we can say, I'm just going to write this out. So 1 plus 2i w plus I w conjugate is equal to 3 plus 5i. Fine. So, what we can do, so I'm going to say, cool, let w equal x plus iy. Okay, so therefore what we can say is w conjugate is going to equal x minus iy. Okay, cool. So effectively then what we've got is the equation that says the following. 1 plus 2i times x plus iy is equal to I x minus iy is equal to 3 plus 5i. Okay, brilliant. So if we multiply this out now, okay, what we're going to get is x plus iy plus 2ix, okay, plus 2i squared y. Okay, and then we go plus ix minus I squared y is equal to 3 plus 5i. Okay, simplifying this out, x plus iy, x minus 2y plus ix plus y. Just check I've got this. Yeah, okay. So we put this all together, and we kind of factorize it now. Effectively what we get is x minus y, okay, minus 2y plus y, plus iy plus 2ix. It's actually plus 3ix then. Okay, so x, right, iy, okay, 3 plus 5i, so we get x minus y plus I 3x plus y is equal to 3 plus 5i. Okay, perfect. So now all we have to do is set the like terms equal to each other. So therefore, x minus y is going to equal 3. That's our first equation here. And the second equation we're going to get is 3x plus y is going to equal 5, which is equation number 2. So, this therefore means we can get the equation that x is equal to 3 plus y. Okay, cool. It's going to be our equation 3. So if we sub 3 into 2 now, here's what we get. We get 3 plus y plus y equals 5. So 9 plus 3y is 5. 9 plus 4y equals 5. Okay. So therefore, 4y is equal to minus 4, which means that y is equal to minus 1. Now, if y is equal to minus 1, what we can say is, okay, cool, x is equal to 3 minus 1 is equal to 2. Perfect. So therefore, what we can say, guys, is w is going to equal 2 k minus y. Okay, so that's just going to equal 2 minus I. Okay. Okay, guys, now for BI, it says the following. It says, on a sketch of an Argand diagram, shade the region whose points represent complex numbers z, satisfying these inequalities. Okay. First thing I'm going to do is draw a big Argand diagram. Okay, so I can sketch this out. Okay. Real. Got imaginary up here. Okay. Z minus 2 minus 2i is smaller than 1. Okay. So Z now remember, this over here is the same thing as saying Z minus 2 plus 2i smaller than 1. Okay. And equivocally, essentially what this is saying is that if this was equal to, if we had z 2 plus 2i equals 1, that's the same thing as having a circle with radius 1, but with the center located at 2 plus 2i. Okay. So, yeah, right, so in essence 2 plus 2i is going to sit up here. Boom. That's the first thing. And the second thing here, arg z minus 4i. What's arg z minus 4i doing? Well, arg z minus 4i is bigger than or equal to negative pi over 4. Okay, cool. Right. So again, it's like that. Okay. But since it's negative pi over 4, it's going to be making an angle like this. Okay, so it's going to be at 4, but it's going to be making an angle like that. So how do we put this on? How do we actually put this on the graph here? First thing I'm going to do is draw the circle. Okay. So I'm going to draw the circle. It's going to be over here. Okay. And over here we've got center. We've got 2. Okay, because it's 2. And 2 here as well. Okay. Next thing we're going to do is label the point 4. So we're going to have 4 up here. Okay. And we need to then do the angle. So to do the angle here, I'm going to do the following. Okay. Grab this thing, put it like that. Okay. That's off the angle. So remember, it's negative, right? So it's going down. So it's going to be going through. Okay, I'm going to have an angle of pi over 4, like this. Okay. Now remember what it says. It has to satisfy both these points. Okay, so it has to be within this, and it also has to be greater than the angle of pi over 4. So it has to be greater, but also it has to be greater, but also has to be within this. So therefore it has to be within here, right? So what I'm going to do is I'm going to shade this in quick. Okay, because that's our area of that we can work in. And what else does it want us to do? Okay, fine, that's it. Sketch. Perfect. So now for II, what does it want us to do for II? For II now it says find the least value of imaginary value of z for points in this region. Right. So how do we do this? So the way we go about doing this is what I'm going to do is I'm going to copy this argon diagram and bring it onto this page. Okay, I'm going to get rid of the BI because we want II now. Now from here, it's just a case of kind of seeing what we can do. So boom, 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 boom. Okay, so here's what I'm going to do. I'm going to label this. So we've got P. I'm going to have P over here. C over here for center. Okay. For R over here. And what I'm also going to do is I'm going to draw a line from this to this. Okay, that's going to represent Q up here. Right. Now, why have I done that? Well, remember, what do they want us to find? The least value of the imaginary value of z. Okay. So that's going to be the coordinates, the y coordinate of P over here. Okay. Which is going to be the length from 0 here to this. In fact, I'm going to give a label here, S. because I'm going to foreshadow exactly what we need to do here. So the first thing we need to do is we're going to say the following. Okay, we're going to say that if I grab this quick, draw a line here. What we can say is CR. Okay, CR is going to equal 2 squared plus 2 squared, which equals root 8, which equals 2 root 2. Okay, CR over here. Why? Because we've done this squared plus this squared is equal to this. Cool. That's the first part. Now, let's see what we can do here. So, let's see. Now, the length PR. Okay. The length PR over here is going to equal. Remember, since the radius here is 1, radius here is 1, what we can say is PR. Okay, so PR is going to equal 2 root 2 plus 1. Okay, because we got radius here plus CR here, so that's 2 root 2 plus 1. Nice. Now remember, we're trying to find the value, the y value of p here, i.e. this PS. So we got 2 root 2 plus 1. But now I'm going to say, fine, what's PQ equal? Well, what we need to say is, in triangle PQR, okay, what we can say is PQ is going to equal, in fact, before I even go there, in this triangle PQR, okay, sine of pi over 4 is going to equal PQ over PR. Okay, brilliant. Which means what? Which means that sine pi over 4 is going to equal PQ over 2 root 2 plus 1. Okay. So, what does that tell us? That means that PQ is going to equal to sine of pi over 4 times 2 root 2 times 2 root 2 plus 1, which means that PQ is going to give us 1 over root 2, okay, times 2 root 2 plus 1, which means that PQ is going to give us 2 root 2 plus 1 over root 2. Okay, now remember, the least imaginary value over here is P, okay, within these bounds, P. So therefore we have to find PS. Okay, it's actually the y value of P, so therefore we have to find PS, which is aka the length, right? So how do we do that? Well, we have to recognize that this thing over here is 4, right? QS. So what we can say is, okay, PS is equal to 4 minus 2 root 2 plus 1 over root 2. If we simplify this out, we can say this is equal to 4 root 2, okay, minus 2 root 2, that's 1. Let's see what I've got here. Yes, we've got 4. Okay, so we've got 4 root 2 minus 2 root 2 plus 1 here. Root 2. Okay, so PS it's going to equal 4 root 2 minus 2 root 2 minus 1 over root 2. Okay, which equals what? Equals 2 root 2 minus 1 over root 2. Right, which comes down to what? We can simplify this down to basically say, well, it's just going to be to take out the root 2, so this can simplify down to 2 minus 1 over root 2, which basically equals 2 minus root 2 over 2. Okay, and that, guys, is going to be the least I can say which least imaginary part of Z, okay? Because we found PS, and that, guys, is going to be the final answer to that question. Alright, guys, now for question 6, it says the following. So the complex number u is defined by u is equal to 7 plus I over 1 minus I. Express u in the form x plus iy where x and y are real. Okay, so how do we do this? Well, number A, express u in the form x plus iy where x and y are real. Alright, so the way we do this is we're actually going to say, well, okay, cool, u is equal to 7 plus I over 1 minus I, but now what we're going to do is rationalize the denominator. So it's the same thing as saying timesing by 1 plus I over 1 plus I, right? So that's going to give us u is equal to 7 plus I for 1 minus I squared. Okay, so u is f going to equal 7 plus I for 1 plus I over, okay, what's 1 minus I squared? Well, 1 minus I squared, that's just going to equal 2, right? So what we've got here is, okay, 7 plus 7I plus I squared, so 7 minus 1, it's going to equal 6 plus 8I over 2. Okay, which equals what? 3 plus 4I. Okay, that's the first thing. Okay. So show us. So we got that. So now says show on a sketch of Argentine points A, B, C represented by U, 7 plus I, 1 plus I. Okay. Well, that's pretty simple. Okay. I think this is a bit more of a simple question, guys. Not necessarily too difficult, but sometimes I throw it in. You know, if the rest of the questions have been quite hard. Okay, so it's pretty simple. we just have to kind of represent this now. So 3 plus 4i. Okay, that's obviously a. 7 plus I. Let's be down here. Okay. 1 minus I. Okay. Well, this is going to equal 1 here. And minus I. Down here. ABC. Now what does it want us to do? Well, by considering the arguments of 7 plus I and 1 minus I, show that tan, right. So considering the arguments, something tells me we've got to find the arguments of these. So, let's see what we can do. So what was part A? So what we found, okay, in part A, was that 7 plus I over 1 minus I was equal to 3 plus 4i. That's what we found. Now it says, considering these arguments, right, so what we're going to do here is going to say, fine, well, the argument of 7 plus I over 1 minus I is equal to the argument of 3 plus 4i. Okay? Cool. And so we can proceed as follows. We can say the argument of 3 plus 4i, okay, the argument of 3 plus 4i is equal to the argument of 7 plus I minus the argument of 1 minus I, which tells us what? The arctan of 4 over 3, okay, is equal to arctan of 1 over 7 minus arctan, okay, of negative 1 over 1. Right, now all we have to do is apply some pretty simple trigonometric rules. So we can say from here that 10 minus 1 4 3 1. Okay, what does that tell us? What that tells us, okay, is if we go back up, yes. Remember, they want it to get to this, right? So what this tells us here is that tan minus 1 4 over 3, okay, is equal to tan that's 1 over 7 plus pi over 4, okay, and that, guys, is going to be the final answer because we've shown it as the question required it up here.